Here is my self-hosted compiler for the Elna programming language. And let us go crazy today and implement static arrays. To test the static arrays, at first I want to have static arrays as record fields. I already implemented some parts. I think that array parsing is implemented. We will see what is already done, but because I am not sure anymore. So we just go to the end of the type definitions and define a new type. Let us call it red. Let us call it R. And it is a record. And this record has field 1 of type word, for example, and field 2 of type array of 3 words. And we will also add field 3 of type word as well, and try to compile it. And we need an exclamation at the beginning, and it crashes, which is actually expected, I think. So at first we will check the parsing. I actually think we need a new stage for the arrays, because it won't be able to compile the arrays with the previous stage. Yeah, let us look at first how the type expressions are parsed. So we have a simple expression is not what we need. This is just a call. This is just a call. We need the definition of this procedure, and it has basically this left square check. So it checks the current token and then calls parser array type expression for the parsing itself. And this procedure, it allocates some memory for the abstract syntax tree node, sets it kind to an array, then it parses a binary expression and it skips a token. The token skipped is the left square bracket, then a binary expression, then it skips the closing bracket, and then it parses the base type and then returns the result. So parsing actually looks fine. Where do we encounter these fields next time? Probably during the type checking. type, pointer type, record type, array type expression, and a name array type expression, array type expression. So it allocates type representation for the array, then it handles recursively the base type, it gets the length of this thing. We actually do not need this variable, I think. Okay, that actually looks fine, I think. Array type expression, and it sets the type size to the base size, to the size of the base type multiplied by length. Which looks fine as well. Elna type declaration, Elna type declaration. Do we have Elna type call for the type expression? This is type declaration. So the type check doesn't visit these nodes because the type check is currently pretty incomplete. I kind of interested where the crash happens. So let us build it once again. And this is the command that fails. We just run it with the debugger and we give it the source. So run. Elna name type record loop is a label, I think. Elna name type expression is the place where it crashes. Elna name type expression, okay. What was the loop? Elna name type record. Okay. So let us find this label. And here we visit all the fields in a record declaration, and here we call this Elna name type expression This is the name and name length. Let us print this variable. So basically we just say that we output a comment into the generated assembly. It is probably something like this, and 0, and then we first write the length, member array current length, and when the name point member array current name. So it outputs into build stage 18. And the file is empty. And it actually doesn't print anything, which is actually, yeah, this makes sense because I haven't compiled this stage yet. The print statement should go into the previous stage. So in the bottom half we open the previous stage, being stage 17, and we look once again for this Elena name type record loop label, and we put the output just here, and now we compile it. Exactly, now we have some output, and at the end we have field 1 and field 2. That does mean that it doesn't visit field 3 at all, so it crashes somewhere near the statements. We know actually that it crashes here, but we can check that we currently visit the second field. So we write field 2. This is the only field which is named like this, so we cannot we can distinguish it from the fields in the other records because they have more sophisticated names. And we need the length of this name being 6 bytes, and the other one is basically this one, but the order is different. First the name, then the length, and if this thing is true, then we print this. We do not need the stage 18 at first, so we can use the top window for the assembly output, and it just prints filled 2. What would happen if I write the value at this memory start pointer? So we just put a space here and write then a pointer output, and then add this thing as argument. Let us see. And the pointer is nil, and it would explain why it crashes. So it basically calls this ELNA name type expression with nil. ELNA name type expression, and this ELNA name type expression expects a tree node being here, and it actually dereferences it, and at this place it would crash. So okay, it means this is the name resolution pass. Before the name resolution we do only the parsing, I think. So if I look, I think I had this compile function, and it calls the name resolution just after the parsing. And what was this memory start? So record fields. It basically doesn't save the abstract syntax tree for the type of the field. Let us look how the records are parsed. So we need parser for the record type expression. Which stage it is? 17. Skip identifier. Elena parser type expression. This is the field type. And this is actually where we parse it. And field name and field length will contain the field name. Let us just do the same trick. So we produce some output only if we encounter a field named field2. I had string compare somewhere. This is the 18th stage. Okay. We go here. Let us remember the line 3215. Exactly. We copy this code. And we insert it in here. But we compare the field name of length, field length, and if we find it, then we print just some string just for testing. So we replace this one with field length and field name and print here and just some string like ASDF, and then we can compile it. Okay, and go to the assembly, and this is the place where we parse it. Now we move this line above, and we will try to print the pointer returned by the Elena parser type expression. So we just replace this S with P, and we print here the address in the variable. So, and it is nil. So our problem is this is that Elena parser type expression returns nil. It would mean that we do not visit this branch. Let us just add an else branch, and we just will print here some debugging information. At first we can just see how often it is called, and we just put a comment else. It is called once, and let us see what is the current token kind. it would be just an integer, and we print the token kind here. Well, the token kind is 0. Token kind 0 means probably that the token isn't known, which is strange. So these are the tokens. An Alexa kind, and it has this left square token. It is used here. Oh, I see. The tokenizer doesn't set the token kind. So we need to modify the tokenizer a bit. The handling of the square brackets, it could be similar to the parents, but probably is not the same, because parents are also used in other tokens like comments. But it is actually a single character thing, so it's just like something like comma, I think. So we just need to add here a case for the left parent, left square, and we assign it the proper token kind, and see what happens. So it is now recognized, and we get a valid pointer here, but the compiler still crashes. But at least we know that we can read the proper token. Let us add the closing bracket as well. And right square, I think. And we add the same stuff to the 18th stage. I think it is here. Is it the same function? Eln Alexa classify single. Yeah, I think so. And we just add these two branches here. Okay. We could check where it crashes now. So this is the same thing that crashes, being the validation stage 17 compiler, and we pass the soils to it. Boot stage 18. And it crashes apparently in this elna name array type expression. Okay. Elna name array type expression. And it is called from the elna name array type expression and name array type expression. So this is everything we have. Let us look at this procedure and we open it in the stage 18, I think. So it would be stage 18 CL, and we look for the definition of this procedure. What it does, it allocates some memory and handles the base. I actually wonder if I broke something. Probably not. I just did it to tokens, handling of the tokens. It wouldn't have other side effects, I hope. So then we get elna3 array type expression, and we get its length. To type kind pointer. This seems wrong. I do not think it is a pointer. Elna type kind, and we have here array actually. But it is the stage 18, we need 17 as well. So the procedure is elna name array type expression, but I do not think that this is the reason actually. This is stage 17. Let us look at this elna type array size. So it has some kind, it has size, base and length. And I actually set all these values. So this is stage 17, this is stage 18, and we want to look into the output of the 17th stage. This is Bootstrap compiler stage 18, and it prints nothing. Okay. Okay, this result length assignment crashes. I actually think it is nonsense. What is length? This is an integer literal. Oh, it is not just an integer, it is a literal. L03 integer literal, and it has value and length. And I know why it crashes, because it is probably a string and not a number. Because I don't any computations with these literals, I just save them as string currently and output into the assembly, because assembly understands integer literals as well. But we actually need to parse the number and save it. What I would like to do is actually print this thing, because I want to see what we have here. So let us print this, and we can just length and length value. Then we need the assembly again, and we do not have any output. this does not make any sense, because length is a pointer. It should be length value actually. So it is nil. And this is the reason why it crashes. Length is the length taken from the parser node, and the parser node is ELNA3 array type expression. So if we go to this ELNA3 array type expression, then we will see the length here, and it isn't set. Let us just move where this type is created. We assign kind base, but we do not assign the length because I just use the wrong field name here. This is the wrong stage. Yes, this is the wrong stage. We need to do the same here. Array type expressions. So we change the field. Base is assigned here because we first have the array size and then the base type. So we just write length here as well. And just call this thing again. And now we can compile it. Okay. So we still need to look how length is represented, because if length is not an actual number but a pointer, then the size calculation for the record will be complete nonsense. So we do not need this one anymore. It can go. Probably we do not need this. So this is the output and it prints a pointer here now. If I try to write it as a string, what will happen? So first we get length, and then let us write length first. If the length is 0, then this is an integer. If not, then it is a string. So we just print an integer here and see what happens. Yes, 1, so it is a string. Let us be more concrete here, so we can find this comment easier later. And now we print the string. Actually, it isn't needed. It is a string. So if I print it as a string, then I should get 3 in the output. So we do have this. The one problem that we have is that these tokens are not null terminated. We cannot use the standard functions for string conversion as is. Let us see where this LNA3 integer literal is created at all. LNA3 integer literal. It will be some parsing function like this one, and it just assigns integer token integer length to these variables. Let us just create a buffer variable of type bird. And what we are going to do, convert the integer string to a number. I have it to do here even. So integer token is the token start, and then we have this token length. And actually we do not need this thing. We can just subtract the token beginning to get the length. So this one can be removed, and we mirror the same changes in the 18th stage. So stage 18cl, and this is what it is called, LNA parser integer literal, and we just create a buffer here as well, and put it into the variables, and we say that we want subtract this thing here. Now we allocate memory into the buffer with the length of the token, so integer length +1 for the 0. And then we we can just zero the buffer first. Data length +1. And now we can copy the string into this buffer. I think malloc actually could return only memory maps return zeroed memory, I think. Okay, that's fine. And now we do memcpi, where we copy into the buffer and we copy the integer token and integer length. That would give us a zero terminated string. And now we just say that the value is A2E and we pass it the buffer and the length is then 0. And now everything will break, I suppose. Crazy stuff, it works. So then we do the same here, I suppose. Exactly. And now it prints nothing because the length is 0, so it just prints an empty string, so to say. Let us look for the printf. This can be removed, I think. What is it? This is for the record type expression, but it should probably just work if we calculate the field size correctly, then it should just work. I suppose I will just remove this stuff. So no, exactly. So now this is a number and we can replace string printing with the integer printing, and length can go, and we can just compile it. and it correctly prints 3. And now we can use this value. So base size is the size of the base type, and the length value is basically the length of the static array. So we multiply the type size by array size, and we should get then the type size for the static array itself. Okay, that looks fine. Let us fix it in the 18th stage as well. This printf can go. Name expression. Array length. Now, since we are parsing the integers, this length field actually shouldn't be required anymore. But I think that I need to save current state so that I can revert the changes if something goes wrong. So we just add this thing. Basically we worked on the 18th stage and on the 17th stage. Let us do this change only for the last stage. I do not see much sense in the modifying the 17th stage further. And it was something with L3 integer literal, and this length isn't needed anymore theoretically, but it will definitely break because we have some places where the length field is actually assigned. Exactly, it crashes, which is expected. So let us see integer literal, and here we have result, and we assign the length here, for example. We can get rid of it. And probably we will look for the kind of this, or for the type itself, integer literal, because there will be further places where it is used. So here we convert an integer into 3-address code, so we just load it as an immediate, and we cannot access this length field. We just use 0 as the length. Okay, value 0, that looks fine. Then we have this character literale. Why is it the result of character literale and integer literale? They have the same structure, I think, the character literale and integer literale, but the character literale actually has a length, because characters can have more. For example, escaped characters have more than one character, even if they just represent a single character, a single byte. So they should be parsed actually as well, but I do not do this. I think I just keep the escaped symbol in the character representation, but we should just parse them later, the same as we do with the integers. So I do not see anything interesting here anymore, but we wanted to continue to look for this integer literal type and see whether it is used somewhere else. Exactly, length, and here the length is this literal, and of course I use the round field here. It should be value, not length, and this goes as well for the 17th stage. So we have this length, and this should be value, not length. Value and value, yeah. Okay, so this is done. This is the 17th stage. This comment can be removed now. So, okay. Let us do something with our example. So in the stage 18th, let us put it here. We defined a type called R, and this type has 3 fields. We will define not only this type but also a procedure f, and we will return the size of this type. And then we open the last generated assembly, build validation stage 18 CL, and we find this F procedure, and it adds 20 into the register, and it sounds about right. So we have two 4-byte word fields, and we have 3-element array. So we have 5 words, and 5 multiplied by 4 is 20, so this is the correct result. The size is calculated correctly. And another thing should also work. We can just say that we get a variable r as parameter of type r, and we return, for example, the second field first. And we'll add here F4 into the register X7. It is the offset, the calculated offset to access the field. It is the second field. The first field is a 4-byte word, so the offset for the second field is calculated correctly. Let us look what happens if we write 3 here. And it is 16, which is actually also fine, because so the whole type is 20 bytes and the last field is 4 bytes. So to access this field we need the offset of 16. This is also fine. So we can remove this temporary code or this test code for now. We do not need it, so this can go. I would like to look for printf, or we can just look at the div. And this is fine. So here just added a comment. This one should be removed. This is fine. Which stage is it? This is stage 17. Stage 17. So here we removed an unused variable, an unused field. This is fine. This is the same. Okay, we basically just have a single printf statement here, and it prints this field too. We can just remove the whole thing and compile it once again. Very nice. And the final test would be rake boot. I think it will compare the output of the last stage with the output produced by the previous compiler. And it doesn't print anything. That means that everything is successful. So as we have seen, I already had an array implementation in place, but I haven't used arrays and I haven't tested it, and we fixed just a few bugs, and now we can at least use arrays in the as nested in other types like records. So record fields can be arrays, and next time we should see that we can parse expressions that use arrays, so that I can assign values to an array element, or for example get a value of an array element that will be probably a bit more complicated, because because things like assignment, like array assignment, or we want to implement array assignment, so we cannot assign array to array yet, but even assigning a single element will probably require new instructions in the 3 address code. I should still think how I will implement it, but we will take care of it next time.